In this lesson, we are going to look at horizontal asymptotes. And so we've already looked at the vertical asymptote and why it exists and how it exists. And now we're going to really examine the horizontal asymptote. You're going to do this by working through a Desmos activity and just doing some eyeballing and kind of explaining to yourself what's going on. To get us started, let's just look at this function. F of x equals ax plus 3 over bx minus 1. And again, we can see that ax plus 3 is a linear function. Bx minus 1 is also a linear function. So we have a linear function divided by another linear function. So what value of x makes the denominator 0? So again, this is helping us figure out the vertical asymptote. And so we know that our vertical asymptote is created by making the denominator 0. So I'm going to start by saying that this is going to be my vertical asymptote. And I want to know when bx minus 1 is equal to 0. So I want to know when the denominator is going to be 0. So what x value makes this true? So I solve this equation. So I'm going to add 1. So now I have b times x equals 1. And because we're multiplying here, we're going to undo multiplication by division. And so I just have x equals 1 over b. So if I knew b to be 5, it would be 1/5. If I knew b to be 1/2, then it's 1 over 1/2. Whatever b is, that's what we would substitute it. So once we know what that b value is, we know that the vertical asymptote would be x equals 1 over b. What happens when the denominator is equal to 0? Well, one of the things is that a vertical asymptote happens. So when the denominator equals 0, one thing is a vertical asymptote is created. Another thing that happens is that the function becomes undefined. Okay, so if we look at, now we're going to explore this, but before we explore this, we have a set of a and b values here and our function. So we want to fill in the vertical asymptote in the table for each of the particular situations. And so we know this information from number 1 means that the vertical asymptote is x equals 1 over b. And so for the first one, I know the b value is 5. So I know that my vertical asymptote would be x equals 1 over 5. So you will continue that on to fill in the rest of those vertical asymptotes. Next, we want to use the Desmos exploration that's already linked. And so I am just going to copy that hyperlink and go over to Desmos. Well, actually, open up this particular activity. You'll notice here's our A and our B. Here's our function. You'll notice that the vertical asymptote is 1 over b, so we put this in just as we did. So if b is 1, so right now it's 1 over 1, you can see that this goes through x equals 1. And then the y value for the horizontal asymptote, which we're going to just eyeball, you're going to write as a fraction. So if we go back to the instructions, so you're just eyeballing the line that approaches, where the graph approaches, and you want to write it as an unsimplified fraction. So if you get y equals 3 over 1, that's what you want to write, not y equals 3. Same thing with y equals 6 over 3. You want to write that, not 2 over 1 or 2. So you want to leave it as an unsimplified fraction, even if the denominator is 1, or if the fraction itself can be simplified into something smaller than that. So you're going to go through and fill these each in by just simply eyeballing them. The other thing you might want to take notice when you're doing this, there's a table that's also down here, and you can kind of look to see what's happening in the table. We'll come back to the table shortly. But this time, unlike in the vertical asymptote lesson, we did not have a horizontal intercept, but in this problem, we both have a vertical intercept and we also have a horizontal intercept. We still have two parts to our graph, okay? But one function, it just has two pieces to it. So spend some time reviewing that. I do also want to take note of, for you guys to finish filling this in and also come up with your answer to part D to the best of your ability before carrying on with the rest of the video lessons. Really spend some time exploring that Desmos activity to see if you can come up with this. One last thing I want to mention here, and that is, what is the constant rate of change of the numerator? Remember that the numerator's function is, we'll just call it f of x equals ax plus 3. So the constant rate of change of the numerator is going to be, constant rate of change of this part is going to be a. And then for our other function, let's just call it g of x. And that the denominator is made up of bx minus 1. So if we call this bx minus 1, we notice that the constant rate of change of this linear function will be equal to b.